This talk actually came out of back in March, we had a night of cloud at Dallas, and I had about 10 minutes to try and cover cloud, and I got through about a third of my presentation. So we represented it and brought it here. I'm a little curious, how many are in an on-prem to cloud, currently doing one? Okay, planning on doing one soon? Came in here because it sounded like a really cool topic. Hey, all right. I've been with CG Infinity for a while now. I've been working in the industry for the last 30 years. And this whole idea of migration and modernization, right? It's a great word, right? We've been using it for 30 years. We're always modernizing the next thing, right? We've been using these buzz terms. And when you start talking about going from on-prem to cloud, right, we're talking about taking that data center, taking those computers, and moving them up into the cloud. And we're going from cloud to cloud, or we're going multi-cloud. We're doing a transition. And there's lots of justification that as devs, we're like, why isn't everybody doing this? I mean, duh, right? It's seamless integration. Grow as you go, shrink what you don't, fail over is seamless, you won't even notice. I mean, we've got these great buzz terms, but they only get about to middle management, and they never seem to bite the bullet. You can't get your CEO to pull we all know it's a great idea, why aren't they? Our leadership at CG Infinity actually put a document out about a week ago about this. When you're taught to speak, when you're taught to engage and interact, you're told to tell stories, right? That's how you keep your audience engaged. But the further you get up that leadership stack, the less they want to hear stories and the more they just want to see the numbers, right? They want to know, pay this, get that. I don't need all the nitty gritty in the middle. And the biggest problem that we have when we're trying to evangelize this and get traction with this within our companies is we have great stories, but they're really hard to monetize. They're really hard to get a dollar number on it. If you take this AWS, if you take this web API and you move it up into AWS, you'll get X amount of profit. How do you get there? So none of the migrations, none of the modernization projects that I've ever been involved with ever started from the dev evangelist finally convincing the CIO, right? Instead, it's always the CIO going, okay, our data center contract's running out in 6 months. So now we're going to migrate to the cloud. You've been telling us about the cloud, so now we're going to do it. The impotence comes from some sort of change, some sort of thing. And the big problem with that is every time they do that, there's always this like drop dead date, this deadline, right? Where the data center's contract ends in 6 months. Can you get us the cloud in 6 months? I guess. Well, if you can't do it now, we'll just sign another 10-year contract and we'll look back on it then. No, we're good. We'll get you there. Okay? When that happens, you do a lift and shift, right? You walk into your data center, you say, okay, how many servers do I have? How much capacity do I have? How much memory do I have? And you just take that whole big old thing and you put an identical copy of it up in the cloud and you copy all your, it's not even a dev thing. It's all an operation. They do it over a weekend and dev knows nothing about it. But then about 6 months later, they get that first bill. What? How much are we spending? That's more than the entire data center used to. That's more than that. You just shot right past all of our budgets. This was supposed to be cheaper, y'all. You said this was going to be better. It was going to be faster. No. We've got big examples right now of companies that are rolling off the cloud. They're like, no, we're going back on-prem. It's cheaper. The problem is there's a difference between going to cloud and cloud native. Okay? Cloud native is when your applications and systems are designed to be on the cloud. You can modernize and just go to the cloud, and get none of the benefits of the cloud. In fact, it'll cost you more. Chart of just some general layout, and we'll start going through some of this as we go along. But your lift and shift is your absolutely most expensive method of going to the cloud, the most expensive way to go from on-prem to cloud. The reason for that being, I said earlier that there have been lots of these modernization projects, right? We've been doing them for 30 years, but this one's different because how we're measuring it is different. For the last 30 years, the easiest way to solve a performance problem was more hardware. Just put more memory on it. Or wait 6 months, the new processor will be out and it'll solve the performance problem. Just keep throwing hardware at it. We've been able to stay up a lot of these old systems, stay alive simply on Moore's law, right? The computer systems double in size, the processing power doubles in size. It's still chugging along on a 1990s code base, but hey, we're good. Then we lift that monstrosity that we've created by throwing more and more and more hardware at it, and we lift that up and we put it on the cloud. Well, when you go to the cloud, let's see, skip ahead a little bit. When you're going to the cloud, you're paying for 3 things, okay? Your first one is data transfer. Every time you transfer data up or bring data down, you pay for it. Now, you never thought about that when you were designing an on-prem system. Data was free. The fact that I went to the server and did a query and went back and used it at the workstation on my desktop application, that's all. I mean, who worries about the line on the internet cable? But now we suddenly take our SQL server and go, okay, we're going to go to the cloud, so we're going to take it and we're going to re-platform our SQL server to Microsoft SQL, and we're just going to leave everything else just the way it is. Now, all these things that we're talking to a local SQL database are now all going across the wire to get their data. And that bill just... Storage. When we were on-prem and we were building these things, it didn't matter, right? They were just hard drives, and you could just add more and more and more hard drives. I mean, we got these terabyte hard drive stacks, right? Who cares? It's cheap. It's easy. Easiest way to solve the problem, you just throw another hard drive at it. Hard drives are cheap. Now we go to the cloud, and we lift this monstrosity of data up that we're always expecting to be available in our SQL. It's all hot. It's all live. It's all the way over here on the most expensive layer because we just re-platformed our SQL up to the cloud, and it's all in hot storage. We re-platformed our file server up to the cloud. It's all in hot storage because we have no concept within our application of being asynchronous, no way to command and reply, no way to wait and get it later. If you built that in from scratch, I mean, you can use a whole lot cheaper file storage, but when you're just lifting and shifting, you can't. All right. For some reason, and I don't know why, but if there's one lesson I've learned in 30 years, big bang fails. The bigger that deployment's going to be, the more likely the thing is to fall off the rails. But these lift and shifts, these cloud migrations, for some reason, they're all big bang. It's like we're going to take our application, and 6 months from now, we're going to go live on a... You're going to do what? Yeah, we're going to rewrite all of it. Big bang fails every time. I could use examples, but I'd probably get in trouble. A modernization, any modernization, needs a maturity cycle. You start with one thing. Get that one thing over. What's the quickest thing I can do? What's the easiest way? It may be a lift and shift. That's not bad, but you can't stop there. It might be simply re-platforming your SQL server. Again, not bad. Don't stop. What do you do next? What do you do next? It's a cycle of, okay, what do we have? How can I put that into a container? How can I move that container up to the web? How can I split that container up into smaller services so that it does smaller things and uses less memory, uses less hard drive space? And how do I go back around that cycle and find the next thing to move up? And the next thing to move up? Because eventually we want to get to that far right-hand column, right? We want to get to that super cheap utilization of the cloud instead of the far left-hand column, the super expensive utilization of the cloud. We have to build that into our system. But if we try to do it with a big bang, we're going to fail. So use fire. The hardest part in any of these modernizations that I've dealt with is coming up with that roadmap, coming up with that runway. How are we going to take small steps to eventually get us to that destination? And that's the trick in this. Where do I want to go? And what are all the little itty bitty weekly deployment steps I can do? Keep my stuff in production to get me to that destination. That's, to me, one of the hardest things in systems engineering. Yeah. Okay. So is that going up or down? That's going down. So first, any question? Anything came up that has occurred to you that you're dealing with that I've touched on?
Yeah.
Great.
There's no power in that. If you go down, but the layer on top of file graphic.
Yeah. And I can definitely see that with an agentic or a predictive AI predicting what files I'm going to need so I can move them up in my storage stack before I actually make the request. I can definitely see an AI fitting right in there and helping in that area. Another thing on AI in all of this that goes hand in hand with this is all of these microservices, all of these, all right, first, macroservice, microservice, what's the difference? Everybody's got a different definition. Macroservice to me is something I lift and shifted. I just took my whole API, I wrapped it up in a container, and I put it up. That's a macroservice. It does way too much. It does way more than we ever intended it to do. Microservice, we intentionally said we want to do this one thing well, and we do that. That's, to me, the difference between macro and a micro. As we move these macroservices up, as we move these microservices up, as we get into this age of agentic, as we get closer and closer to serverless, it's one of the newer things that's a driver in these modernizations right now, because these agentic AIs need these microservices. They need these serverless performance categories in order for them to be able to leverage activity. When you want your agentic AI to go do this little thing, you need something for that agentic AI to be able to call. So if you get to the point of having hopefully serverless, but if not serverless, containerized microservices, then you've got those available as we get into this era of agentic AI to keep those things up. So where do you start?
Yeah.
Start with a lift and shift. It's where everybody seems to start. It's not where you have to start, but it just seems to be where everybody starts. You take your API, you take your database, right? Hopefully you're going to replatform your database. Replatforming is taking from Microsoft SQL to Azure SQL. It's not a big move, but there's some variances in there, and that's a replatform, right? That's what I mean by a replatform. Step one, lift and shift, because you're going to have to do that anyway. Step two, replatform, right? Don't move your SQL server literally into a container and literally put it in the cloud. You could do that, I suppose. Replatform it, right? Take that SQL server, take that MySQL server, and just use the built-in services on the cloud platform that you're looking at. That goes to replatforming, right? We've got all of these different ways of replatforming, like Microsoft SQL to Azure SQL, MySQL to Amazon RDS. All of these are just taking a system that we are very familiar with and moving to an almost identical system up on the cloud. Your macro services, right? That's taking them, putting them into the containers, moving them up into the cloud, using Kubernetes, getting aware of Docker, getting aware of, I swear I saw a guy that was hosting Windows 95 in a container. Like you can put anything in a container and put it up in the cloud and then make lots and lots of them. Yeah. Not saying you should, you can, right? We went through a whole process of hosting PHP in containers so that we could reproduce the functionality within the PHP container. It was a trip. And so how do I break that macro services, that big honking beast? How do I get that thing broken up? How do I get microservice chipped off of it, right? You got the strangle fig, right? Well, I assume we all know that one, right? Where you start replacing the inside, and it gradually, as you replace small components and pull them out, put them into microservices, it gradually just overcomes the whole form. It strangles the legacy system. It strangles the microservice gradually as you pull chunks of that code out into your microservices. Forked monolith, I've used this one quite a bit. You have two Git repos, okay? You have your Git repo. It has your web API in it. It has your microservice in it. You fork it, and then you put both behind both Amazon and AWS have a API hosting platform that will allow you only to reach certain endpoints on certain systems. So now you have two different code bases, and the only difference between them is what endpoints this one exposes and what endpoints this one exposes. And now I just start deleting code. What don't I need in this one? What don't I need in this to support those endpoints? I can just do a split monolith or a forked monolith. No time. So, serverless container. Right, we all know serverless isn't truly serverless. Serverless is just another way to say we don't deal with it, right? I don't have to manage the server. I don't have to get at the operating system. That's the chiseling. Because they're just containers, right? AWS and Microsoft are just spinning up containers and calling them serverless. What does serverless give us? Serverless, how does it get us to that far right compared to being on the far left? Well, that's your compute. That's how you save your compute. Right now, if you have an on-prem server, or if you're using VMs in the cloud, you have to provision either one for 70% of your peak, right? You can't go back and say, what's the most memory I've ever used on this server? Okay, that's exactly how big the server is going to be now, right? Because you're going to kill yourself. The rule of thumb has always basically been 70% of your peak. That way you've still got that 30% of growth room. Well, when you go to VMs, when you go to containers, if you provision all of that at that peak, you still have to provision at that size. That's still 70% of your peak. But serverless takes that away because it only runs when you need it to run. It's not sitting there occupying that CPU allocation all day long. You're not paying for it all day long. You're only paying for it when you need that functionality. Then the functionality spins up, then it executes, and then you move. Whoa. So we still have 5 minutes left, but there are no questions.
Through also like the architecture that those listen on secure video don't that thing platforming. Right.
So yeah, so personally, I find a lot of times these words get intermingled, right? You start talking about a refactor and an abstraction. I guess along some of those same lines on refactoring, I'm sure if you've been to any AI speech today, someone's told you that AI is built on data. You have to have good, clean data in order to be able to do AI. Well, now we're in an age where we're doing AI with code. And the biggest struggle I have when I'm starting to try to split up these macro services into microservices or take my microservices to serverless is the code itself. We've been charging up our tech debt for so long it's not been a big deal, but now we're in there in these guts trying to pry these things apart, and we're trying to make, and now the quality of the code has suddenly become the key limiting factor on my ability to meet my deadline. I mean, it's always been there incidentally, but now it's front and center. All these cool AI agents that are coming that are going to help us do all of these steps along the way, they all expect clean code. They expect to be able to read the code, work with the code, cut code apart. If you've got a pile of spaghetti, no AI is going to be able to get in there and help you get that divided up. So if there's one thing to do right now to prep your way for AI, to prep your way for modernization in the future, it's clean code. Get the code cleaned up so your AI agents can get in there and see it, read it, and work. Anybody else? All right. Well, nearly the last session of the day, so not a lot of interviewing. I understand. So, thank you for coming.